Good morning.
Hey, Pam. I think it's just the two of us. Rob has a conference and Rose contacted me and says she had family things. So we can, let's just go for it then. It's just two of us. It's a really interesting conversation. How far did you get?
So I watched the first hour and then I started skipping around and I found some interesting bits and pieces, but there was no timestamps. It's really hard to navigate, and
I agree.
Perl is kind of hard to understand at times. Like I really don't understand his accent, or sometimes he just tries to fudge things, like he doesn't say what needs to be said. So I mean, he's getting old, so yeah, there was some interesting stuff. Actually made me realize, like, maybe you can help with this. Like, so now we've taken this course with Robert, the causality. We have like read all these papers about causality explanation. I just realized if somebody asked me like right now, what can you do with causal inference? What is the top applications? I have no clue. Like, I don't think I know. Because all the courses, like including Robert's course, they start with this I would say marketing spiel of, okay, neural networks don't have causalities, all correlations. We need causality because babies have like understand causality, and for any intelligent sort of machine, you need causality, which is fair. But then they go switch to these sort of tree node sort of networks. They say, oh, you have to already know the causality, you put it in there and then you run. So somehow it gets disconnected. I guess they lose me at that point. Like, can we do causality now or not? Like I still, I guess I am missing what is the killer app right now with causal inference? Like, or is this all futuristic? We're hoping that eventually use some of this machinery for like the future generations of AI, or is there anything useful you can do with these right now?
Great question. So Wolfram actually asked that question to Pearl.
Exactly, yeah. That's how I realized that I don't know the answer to that, and I felt like I should after all this time, like studying these things.
Okay, so I'll try and answer your question, but it's a rather indirect answer, and maybe we can explore it together. So my understanding of neural networks is less than my understanding of causal networks. Do you understand neural networks? Did you go through?
Pretty well.
Okay. So my understanding of neural networks, such as it is that they are inductive, right? They just essentially capture patterns in data over time, right?
Yeah, I mean, not necessarily over time. It depends
on
over
exposure to data, whatever that might be.
Yes.
But sure. So things that occur often stick around, and things that don't occur very often fade away or get lost in the background, kind of thing. Is that like if I'm looking at a cloud and I see a face in the cloud, and I've seen lots of faces before, and then I did work with neural networks for a number of years doing facial tracking and body tracking, and they hallucinate all the time. They see people that aren't there. You know, there's a configuration of shadows.
Pretty common. Yeah, yeah. That's pretty common. Yeah, yeah. You could get things that you don't expect for sure, and it's out of your control.
Yeah. So, and the other key difference between causal networks and this is what I learned from the video, and neural networks is causal nodes have names and neural network nodes do not. Do layers have names in neural networks, or not really? Do regions of the network?
No, but even if you train the same network twice, you're going to get completely different distribution of weights. So there's no meaning to the weights. It's just whatever based on accident and your random number generation, the weights end up being. It's the only thing is that, like, it has meaning if you go to earlier layers or the later layers. So the earlier layers are focused on more fine-grained features in your inputs, whereas the later layers build on top of that. So it's like a hierarchy. So you will notice more patterns.
Yeah, I understand. Yeah. So each layer feeds on the next, except when it doesn't in special kind of networks, which are used in vision, where they have these kind of What's that? What are they called? I can't.
Skip layers.
Skip networks.
Yeah, skip layers is still, you will still go through. The skip layer is just there to let the gradient flow backwards so you can train the models. It doesn't really change anything with the weights.
Okay. All right.
But,
so
yeah.
Now we get to my point, which is my whole point in this is I'm working on this kind of intuition, and it's probably a thesis and a paper, and it's been disproven 3 times, that my interest is in creating generators or actors from actor-critic networks, right? So I'm trying to generate, let's say I'm trying to generate a landscape that I can fly over forever. And as I fly, new landscape is created. So my understanding is that causal networks are very useful in that motif, in that you can construct. So the goal of the game is to have the generator generate something the critic can't distinguish from reality, right? So we have data, but the only person that has the data is the critic, is my understanding. The actor doesn't have data, it just has the critic. So the actor draws a picture and the critic says no, and the actor tries again. And the critic's cheat sheet is reality, right? Data from the real world. So there's no neural network here. I know there isn't.
But I guess I'm familiar with actor-critic in the context of RL, but what you described is GANs, generative adversarial network.
That's right.
Yeah. That's all neural network. There is no causality there. So I don't know I guess I'm not familiar with using causal. How do you use causal models to generate procedural environments, I guess?
Okay, so when I create a polygon, it's a polygon, right? It's not just a bunch of nodes, okay? I need to name things in my generator because it's hand constructed by me. I can't. Are there GAN-based geometry generators? I've never heard. I've seen image generators. I've never seen geometry generators.
Well, it depends on what you put in as your input. I mean, if you like lots of polygons, you could have that as the ingredient in your model instead of pixel. I mean, people often go with pixel because it's more challenging and you might get more interesting things. But if you know what you want, there's no difference in what is your primary object in your generator, right? You can do it with anything. So where is the causality in here, I guess? So if you want to use polygons, why do you need causality?
It's a good question. So when we're trying to create an expert system, so if you look at my current simulator, my friend Mike created an expert system, a spreadsheet where there were columns, and the columns have names, and the columns have distributions, and we basically create a list of different variations of these, whatever they are, agent types or dwell points, or whatever you want to call them. There's different objects in the world. The system has to talk to humans, and humans have knowledge they need to encode. So my understanding of the value of causal networks is they allow humans to encode knowledge efficiently, is my understanding.
Okay. So yeah, that part I understand. Okay, so if you have a set of knowledge, you know what things connect to what, because you want to encode that, and then you generate data that respects that distribution, you can use that. Okay, so that I understand.
Right, and so the second part of that is how do you express that knowledge? And the answer is as an explanation. You can do it as text, or you can do it as a Markov system where all the input variables are completely independent, or you can do it causally, right, where you have some interdependence between parameters that is driven by distributions. Okay, so so really, I guess the point is that causal networks allow humans to efficiently transmit knowledge into a model that can be probabilistic and will always generate results consistent with a human explanation itself.
Okay, that's fair enough. Okay, that makes sense. So, but then I guess I would say that is, maybe it is, well, I'm just thinking out loud, but maybe that's not what the main ingredient that's missing from neural networks, or if you're trying to develop a generally intelligent system, that's not what's missing, how to ingrain what humans know into a system. What's missing is how to discover that connection. Because if you already know it, you might as well, I mean, there's maybe causal networks is one way to write it down. There could be other ways to write it down. A lookup table will do. And the probabilities are trivial to calculate from a lookup table. I mean, I guess but I think causal inference is supposed to be more, right? Because you have that do calculus, you have the other things that you can do to gain knowledge about the system besides just putting in what you think is true already. Because I feel like that's too much bias, right? Like if you think you know how everything works and you put it in a causal graph, somebody else comes in and says, David, you're wrong. This is my causal graph. And then anybody could generate their own, right? There needs to be a correction mechanism, I guess. That's what I'm saying.
Yes, yeah. So I have a complicated response to that, but so I can't come up with a situation where I would do what Robert does in the course, where he is, look, somebody comes to him with a question and he uses causal inference to create an answer for that person. So I don't know how to use this stuff efficiently in a human-to-human model. That's very difficult for me to understand. So I'm just making it clear I don't understand that. But let me draw my classic picture here. This is kind of where I'm at these days. So basically we have a series of actions that we can take, all right? So we can, these are interventions, if you will, actions that we can take in the world, and they're down here, right? Mm-hmm. And then we have essentially the pot, right? Some sort of a, I just used the motif of a pot. And in here is what I call the soup, which is basically just decaying symbols. So if I'm frightened by something, then something's going to put a lot of symbols into the soup saying I'm frightened, right? And so I'll be frightened for a while until those mm-hmm. symbols kind of fizzle out, and then something new will come in, and then something new will come in. Mm-hmm. And these actions at the bottom are sampling the soup, right? Should I run away? Should I run away? Should I run away? And if they sample the soup and the soup tastes like we should run away, then we'll run away, okay? So actions are mediated by our current state, if you will. But our current state isn't static because there's decay going on, right? There is active processes going on, removing certain symbols from the soup. There's new, so if we have an inductive system, right, like induction, then it is adding symbols to the soup based on its perception of the world, right? So we have some sensor over here. That sensor is sensing something in the environment. We have a memory. There is a loop here. One of the actions actually tells this thing to remember whatever you just did, do that again next time. So there's loops here. And so this is inductive, right? This is classic induction, associative learning, no reasoning, no logic, neural networks, if you will. There is a subsystem that's doing this, right? Many people would call that system one. Mm-hmm. System two is a bit different, and it's more causal in nature. And in system two, we have a graph of nodes. It's more graph-like. It's called a map in Tversky's book. She calls this a map. But basically, we have a different system that can also generate symbols that go into the soup that uses a different mechanic, right? This evolved separately from this. So if you look at cell biology, it's very much this, right? So the surface of the cell has some structure on it that when it receives something from the environment, it generates a transcription factor. If there's enough of that transcription factor, the DNA will generate, you'll trigger the DNA to create a new protein. We can think of that as a function. That then affects the world. We've made a change. But if this thing here is pumping in X and this thing here is pumping in not X, we can cancel out the inductive response. So to me, causal systems, go ahead.
Question, sorry to interrupt. So is there an arrow going from your system one, the inductive loop, to the map? Because presumably part of that map was learned, right?
Yes, yes, so, sure. I mean, this is very vague. I'm just trying to give you a sense of how so basically there are many systems, right? There's a bunch of systems over here which aren't actually responding at all to the outside world. They're actually looking at the soup, right? So they're actually, this is called apperception in Kant's world, right? This is in a sense where they're really just saying, oh, okay, there's too much of this. We need to take some of that out. And so it's putting stuff back in. So there are all these feedback loops that are, taking stuff out of the soup, putting stuff in. Oh, you're tired now. Oh, okay, it's time to go to sleep. Oh, and I'm hungry, or I've got a headache. So there's all these internal systems feeding into this kind of very vague soup, if you will. And there's a whole bunch of systems. So I see them as being complementary. Like reinforcement learning is great, but it's just one of the systems that we can use to improve our chances of survival. So I see them all as being participating. I don't have enough knowledge to understand how they might interact with one another. But this is my general thesis. So I'm trying to build my agents so that they have this kind of soup, if you will, and that they can do inductive learning. So the way that we do that is, if I've seen you 5 times, then inductively you are now familiar to me, and I'm more likely to greet you and say hello. And then we move into different mechanics at higher levels and so on. So there is
how do you encode this in your agents? Is it like a bunch of if, else, then conditions that you write down by hand by thinking about it? Or is that something that evolves out of simulation?
I'm trying to go from the former to the latter. I'm not there yet. In the commercial app, well, it's not a commercial app, but sort of commercial application that it's being used in, explanations are important. So we decided to not make it fully automatic, but personally, I'm very interested in making it more automatic. So yeah, so basically, I think what we could do, like if you think of Asimov's 3 laws, we might be able to encode those over here as a separate system, right? And they're observing the world, and they can make very, very direct, kind of very strong changes to the soup, if you will, and have a very strong impact on the agent's behavior. So the benefit of this system is that it is both inductive, but you can put in, cars, finite game rules where there's boundaries and all this other stuff. So I don't think of any of them being the answer. I think that they're all the answer, which is I don't think that's a very common view, but
no, I really like your picture. I think it makes sense. Yeah, and I think what's missing is some picture that integrates all of them together. I think probably most people agree with you that you need both system 1 and system 2. Probably most people agree with you that neural networks are mostly system 1, and probably people will say maybe symbolic AI is a candidate for system 2, but that hasn't really been made to work yet. It's hard. That's why I was interested in the arrow from system 1 to system 2. Is I think that paper that you proposed, the causal neural connection, is trying to get at that, right? How do you go from system 1 connected to? Because if you manage to connect it, then presumably you can build stuff up from the bottom up, and then they interact with each other, and you're still missing a lot of the other stuff that you had in your diagram, but at least I think if you can connect system 1 and system 2 in a coherent way, you can make progress. Whereas right now we're sort of stuck where on the one side extreme is the neural networks, which is just sort of inductive reasoning, as you were saying. There is no reflection, there's no thinking going on. It's like one shot, you input, this is the output. And then the reflective part is not there. I mean, causal inference, I guess, tries to get that a little bit, but I think if you have to sit there and define the nodes and all that, you've already lost the battle. Like, it's not going to be helpful, because even in human minds, like, you can like on demand generate new nodes, right? Like, you can imagine new kinds of nodes, connect with it, play with it in your mind, experiment with it in the world. Like, I don't think there is any causal graphs that can generate nodes on demand out of nowhere and experiment, right? Like, that's kind of thing, at least I
So
haven't
you
seen.
could start with a fully connected graph and then use a genetic algorithm to cut links between the nodes and to flip directions of arrows between the nodes, and then
Sure, but fully connected between what? Like, I'm just saying that you can
fair
generate
comment,
new
yeah.
nodes infinitely, right? Like, you can,
Yeah.
if you just sit down, you can keep generating new nodes of different type, right?
So there's a concept in category theory, I think I talked about it, called the adjoint. I think there's the correct technical name, and it has this idea of what is known as lifting, which I also talked about, where when you receive data, it is a representation of something else, and so information has been lost, right? So if I measure something, I don't have the thing in and of itself, to use Kant's language, I just have a measurement of the thing, right? So data was lost. And so that process of measurement and representing something as a lesser kind of a series of numbers, that is called forgetful, right? So we forgot, we forgot some information here, right? So we have some information, but we can't reconstruct everything because we forgot a bunch of stuff. And so when we lift it, what we do is we have a model, bad or good, and there's any number, like, you're free to have any kind of model that you want at a high level. And then you can apply the intervention to the model and not to reality, and then predict the outcome in reality by seeing what values you get.
Yeah.
So I believe that this lifting and then testing back to reality is what I was trying to get at with this this idea of having a genetic algorithm to speculate between different models. So we need a model generator. And as you say, the model generator needs to have nodes. And I think those nodes do come inductively, right? I think we see patterns in the world inductively. We lift those up to we give them names, and then they become actors in the high level networks. So that's one way of thinking about it.
No, I like that. And I think the same themes repeat in many different, like, maybe somewhat disconnected fields. Like, what you described is what people like in neural networks, they call it representation learning, where you go from a high dimensional input to some low dimensional version. Of course, you're losing information, but you think that you have extracted what's useful for what you want to do in that low dimensional space.
Mm-hmm.
And then in GANs, for example, you learn how to go the other way around. Like, given that low dimensional, like, even noise, how can you generate outputs that are reasonable, but they're like infinite possibilities of where you can, depending on how you want to limit your model, you're going to generate different things. So that's the neural network one. But then in information theory, I guess what you describe is just compression, right? Like, you're compressing and you want to decompress or go the other way, you will have to hallucinate new things. And that has to be based on a model or random noise. It could be based on Occam's razor, try to minimize whatever you're guessing. So I think that the same themes like repeat in all the fields with different terminologies and all that. But yeah, I think that's the right way of thinking about it.
Well, that's good news. So yeah, so I've been trying to, so my true interest is in generative models, where, imagine, if you will, and I can give you a demo if you're curious, where you can fly around an environment, right? And it's non-Euclidean. Okay, so as you fly in a given direction, a mountain range appears in front of you, and the mountain range isn't very interesting, so you turn away from it. And as you fly in another direction, a forest appears, and you're more interested in forests than mountains. And so the generative system is responding to you, and you are essentially the critic. And it's like, what did you want to see? Did you, so it's generating, it's free to, it's hallucinating different possibilities. And then you as the critic are navigating towards the possibilities that you care about. But it's open-ended, like it's not a finite three-dimensional world. You can go back in time, like you can rewind and essentially explore a different path, if you will. Like if you're in a nice place and then you wandered off into this is bad, you can go back to where you were and then explore forward again. But it's non-Euclidean, right? It's Escher's Angels and Devils. I think you've seen that.
Yeah. And you might like this paper I just shared. It's a DeepMind paper. It came out a while ago. So they managed to find a way to generate synthetic worlds that are completely procedurally generated. They're infinite, but you can interpolate in a continuous fashion between different environments within that game. So they found
Wow.
They did a lot of math to come up with it. Just go read. I don't know if I don't think they probably don't make their environment freely available, but just the ideas you might find interesting. But they can basically generate new environments ad infinitum based on some like shapes. And so they do decide on the shapes. There's a bunch of boxes, things, and then you just generate these things procedurally. And so their point is, if you have agents that have to learn to live in all these many different worlds and do different tasks, they will eventually learn things that are generally useful regardless of the environment. So that's sort of their spiel. It's a very large paper. It's like 50 pages, but this is the blog post I sent to you. If you can see the diagrams there, but I think it relates to what you're trying to do.
It's just an abstract. So can I download it? Where's the download button?
It's on the left.
Download. Oh, there we go. Oh, okay. Oh, definitely. I'll take a read of this. That looks really cool.
You can see it's a simple world, right? It's like a bunch of different color blocks that are put on top of each other. But
yeah, so in my situation, what I would want to do is I'd want to give architects the ability to put on a headset or just fly around in Quake to see different variations of their building, right? So they would say, this is my design. There it is. And here's a subtle variation, and here's another subtle variation. And they can literally just fly from one to the other. And if they spend time on this one, then I'll generate variations of that. And so the idea is to try and use the system, the AIs and the agents as well, because the agents live in the building, and that because they live in the building, they gain insights about the building that we can then share back to the architect and use to generate alternatives where the agents are happier or more social or less social or whatever you want. Yeah, so I'm trying to, yeah, that's what I'm trying to do. I'm also, there's another kind of very strange goal, which is I'm trying to, the tacky terminology I use is give system one a voice. So when we, it's hard to describe. So when you wake up at the first moment you wake up in the morning, right? You have to kind of reconstruct your world. Where am I? What am I doing? Like, oh, right. Okay. Yeah, it's Thursday. I've got a meeting at 9. Oh, shit, I need to get up and go. Okay. So that's system two, kind of building a map, right? So this is map building in the world. But before you build the map, you are, in Kant's terminology, in a state of totality, which means that system two is turned off, right? Like when you're asleep, you can dream and all that cool stuff. But basically when you wake up, system two doesn't have anything to hang on to. And so in Kant's world, he calls that a totality. Now, my friend Bernard, who I'd love you to meet, by the way, he is a professor at Simon Fraser who works in virtual worlds. And we're collaborating on a project together. And one of the reasons I'm trying to build this kind of immersive environment that's very visual is I'm trying to see if we can use have you looked at VR at all, sense motor feedback and all that stuff? Have you looked into that?
A little bit. I almost went for work for Facebook for their Meta thing. I had an interview. I decided not to go, but I know a little bit. But that what I was interviewing for was some eye tracking software within the goggles, but I don't know the entire. I don't know the entire.
So that was where I came from before I came to machine learning, because I was building headsets and eye tracking and all the machinery and all that stuff and all the cognition. And what I found was that what was lacking in VR isn't actually technology, it's cognitive science. We don't actually know very much about how it works in your head. And so that's actually why I got into cognitive science, is that after I built my headset and I couldn't come up with technical solutions to stop people getting sick and all these other things. And that's how I struck up this collaboration with Bernard, who's been studying this since his PhD. Anyway, so this gets into the cog side, but basically I'm trying to use the generative systems and the machine learning and all that stuff to drive virtual experiences so that you don't have to engage system 2, and you can just kind of have a non-language experience where you're not typing or reading, or you're just seeing an environment, but you can move in that environment physically by flying somewhere else, and so on. So yeah.
Is it fair to say, like, I like the expression you use, giving your system 1 a voice? Would you say like feelings are a voice of system 1 in humans?
Yes.
Like what you feel? Yes. Okay.
Yeah, so
you
basically,
probably know Damasio, right? Like you must have read Damasio, Anthony Damasio. Like you might really, I think you would really love his books. He talks about, it's hard to explain.
A lot of this stuff is very hard to, Damasio, as in the guitar pickup? Antonio Damasio, right?
Yeah, yeah.
Oh, interesting.
He has a book, I'm just looking for it. What's it called? Strange Order of Things. So basically he inverts like the common knowledge or common, I guess, hypothesis that is like your mental processes giving rise to feelings. He goes the other way. He almost says feelings are primary and then they generate your mental processes. He goes back to like evolution and how like feelings came about, and he talks about cultures. Like it's a very different view of things. I really enjoyed that book. Just give it a try.
I will own it in the next 5 minutes. Yeah, very much so. Yeah. So yeah. So this is why I use the soup model, right? Because the emotions are the systems that are tasting the soup, if you will, right? So
yeah.
But so that's generally where I'm going, and I'm very curious. I see causal models as a very efficient means of communication between people, right? So if I show you my causal model, I'm showing you my belief system in a way that you can understand it. So I certainly don't dismiss causal thinking at all. So if my agents were to start passing knowledge between each other, which is something I haven't gotten to but would love to, this is what I've been working on with Rob Neal, which is in economics, there's this idea of information, right? So if you have some information and that gives you an advantage and you act on that information to make that advantage, can we reconstruct what the information is that you have by your actions, if you will, right? So if somebody starts buying IBM at a rapid pace and we don't know why, can we try and infer the information that they have gained that is the cause of them buying IBM?
Yeah.
So there's that part of it as well. But generally, I'm just kind of wandering around the space trying to build a map, as it were, myself. And I find this very, very interesting, and it's directly related to what I do. So, you know, I'm very, very
cool. No, that's interesting. I guess I'm coming at it from a slightly different angle. So what I'm trying to do, like, look at multi-agent system, which I think your system is an example of. But I guess what I'm trying to understand is So a lot of those things, they could go in many different directions. Like one is like, how do agents interact with each other? How is the information propagated through the system? Like try to understand cooperative versus adversarial behavior if you're trying to outcompete everybody, or you're trying to so there's a lot of stuff from like the complex adaptive systems where, like, forget about intelligence. Like imagine these are like spheres with a little bit of a memory and a little bit of thing. And so, like, think of an ant colony, right? Like I think I brought it up last time. Like if you look at an ant colony, it exhibits very, very complicated, complex behavior, but each ant is really stupid and doesn't really know what it's doing. It just responds to local stimuli in this little bubble around it. And there are people who study this, like E.O. Wilson, who passed away, was the world-renowned sort of expert. And so I guess I'm trying to understand so I feel like it's almost like a three-body problem. Like it becomes chaotic. So if you have a couple of things that are stupid, they interact with each other, you can study it. As soon as three particles start interacting, it becomes chaotic. Now imagine the three particles are smart and they're trying to outcompete the other particles. Then it becomes like completely out of control. So understanding the equilibrium in terms of like game theory, or in terms of what you want the social outcome to be for everyone, I think that sort of thing is pretty interesting. And what I like is you can take it in many different directions, like economy, it could be physics, it could be multi-agent reinforcement learning. And I guess what you're doing is also an example of something you can do with it. Yeah.
Did you read the little book on subsumptive robots? I've forgotten who wrote it.
I don't remember. What's it called?
Book. I can't remember. Behavior-based design. I own the book. I'll look it up and post it to you. It's a very thin book. Don't get it from the library. You'll read it in 5 minutes. I'll ask my friend. So many years ago. So basically what this guy did is he built robots that have brains that are 2 wires, right? So you have 2 sensors at the front, you have 2 motors. And if you wire the sensor to the motor so that more light on this side causes this motor to go faster, it always runs into darkness. Right?
Okay.
Always, right?
Yeah.
And then if you wire them like this, there is no brain, it's just a wire, then they are light seeking. And you can put this robot down anywhere in a room and it will run to the light all by itself, right? It's 2 wires and it exhibits intelligent behavior.
Yeah.
And he takes it a little bit further and he gets them to form into circles and to essentially do amazing things. And you open the box and it's a wire. It's really, really interesting.
It makes you wonder, like, is that intelligent behavior, or is it because we are intelligent and we ascribe, like, we anthropomorphize the thing and we imagine it has a goal, we imagine that it wants something. So maybe all that intelligence is our interpretation of what's happening in the world. It's just mechanistic. Maybe even we are not intelligent. We're like responding to a bunch of different stimuli, right?
Yeah, maybe when you open up the box and you really see what's going on, you find 3 wires.
It's a scary thought.
Yeah, it's an interesting one.
One thing I wanted to ask you, so I guess these are 2 related questions. I guess one is, so I have $3,000 of professional development money to spend by the end of March. Okay. Because everything is virtual, I can't really go to conferences. So I'm asking people if they know of any training programs, any sort of courses, or I don't know, really good books that are expensive that normally you wouldn't buy. Is there anything you would recommend? And related to that, so I know you built your simulator in Unity. So I've been meaning to learn about Unity. Is there, like, do you recommend like a training course, or how did you learn it? Did you just go through the documentation, or how would you recommend learning? Let's say I wanted to become an expert Unity developer. Like, well, how would I go about it?
So a long time ago, in a land far, far away now, I wrote a computer game on an iPhone. And it was have you played Subnautica, or do you know what that is? Okay, yeah, so basically you're a diver under the water.
Okay.
and you're swimming around under the ocean, and you're picking up treasure, right? So it was a full 3D game. You swam around using your phone. It all worked. And at the time, the iPhone had just switched from the old world graphic system to shader-based, a shader-based system. And so I had to build my own game engine from scratch, which I've been doing for a very long time. So the way I learned Unity is I built something just like Unity myself.
Oh wow, yeah, that's a very hard way.
Then
of
I mapped
learning
all
it.
the concepts that I had to invent to build my own game engine, and then I
What was it
Unity.
in? Is it C++ or Java or what?
So everything on iPhones at that time was in a language called Objective-C, which I would not recommend. It's a reference counting language, is not very interesting. And then they moved to a very nice language called Swift, which I would recommend. I would think that Swift is a
I know a little
language.
bit about Swift.
Yeah, it's gorgeous. So I didn't really learn Unity in the way that you're supposed to. In terms of really good courses, I'd have to think about it.
It doesn't even have to be limited to courses. Like I don't know, like maybe I feel like I'm not being imaginative enough of what this is a good problem to have, right? How do you spend $3,000 in 3 months and learn something? Like I feel like maybe courses I'm being too short-sighted. Maybe there's other ways of learning. Maybe I should just travel to Santa Fe Institute and talk to people about complexity. I don't know.
You should do that. Yeah, I would go to the first. My first port of call would be Santa Fe Institute. Are you interested in very different perspectives?
Yeah.
So there's a group called Vision.
Okay.
Have you heard of a guy by the name of Maturana? You probably haven't. Okay, so Maturana was a kind of, he was one of the people that's essentially was responsible for the New Age movement. I'm not sure. I find it interesting. So I'm in many groups like this one, and another group that I'm in has a bunch of vision people in it, and they have a very, very different perspective on things.
What do you mean by vision people? This is not computer vision, right? This is like
no.
The future
okay, so there's a guy by the name of Fernando Flores who you've probably never heard of. And he wrote some books, and he had, at the time, some pretty interesting ideas about how we move in the world and blah, 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 speech acts and other things. So he kind of takes the explanation stuff that we did a while back to a whole new kind of level. And Maturana was his inspiration. So there's a book called Being and Doing, I think, From Being to Doing is the last one. But I find it right on the edge of what I'm willing to kind of seriously contemplate. Like they kind of hover on that boundary between BS and something. Yeah, so it's out there, but I like that. I mean, I like being challenged at the boundaries. So I find it interesting. They have lots of courses, but they're very you pay somebody $500 a month, and then you join a group like this, and then there's homework and you have to do stuff, and it's all very structured. I've never done any of those.
I still need to convince that this still has to be paid for by my employer, right? Like I have to convince them this is related to.
I'm just literally trying to come up with something that's not, because you're so well read. I think Santa Fe Institute would be awesome. I would check out King's College London and see if they have any. That would be very interesting. I would highly recommend learning Haskell. I think Haskell is a remarkable language. So you might want to look at Graham Hutton's courses online, and maybe you could do one of his Haskell courses. I don't think I'd build a system in Haskell, but man, it's a really, really interesting system to think in. So for you, I would say Haskell. And I mean, category theory, yeah.
So you don't need to know like the theory of category theory to learn Haskell?
I don't know, because I learned category theory and then I learned Haskell, so I can't answer the question. The lecturers who teach the courses on Haskell claim you don't need to know Haskell to know category theory.
Okay.
So yeah, I would suggest doing an online course on Haskell. And if you do pick one, or if you do find a course that you're interested in, let me know. I might join in if that's.
Who was the course author that you mentioned?
Graham Hutton, University of Nottingham.
Okay. How do you spell Hutton?
Hutton, Hutton. He wrote a book on Haskell.
Okay.
Where does Bartosz Milewski work? Do you know? Is he? I don't think he's an academic. I think he's like.
Could have fooled me. I can't imagine him doing anything else.
Really? Because he doesn't publish papers. He just writes a blog.
Okay.
Yeah, I mean, I actually found him to be very slow at getting to the point too. But I was just so curious about what the hell it was all about. I went right through it, and right at the very end, you kind of get the punchline. And when you read the Stanford Plato article on category theory, the first thing they talk about is the guys who invented it wanted to do it because they wanted to get to the adjoint, which is the thing I've been telling you about. And you get to that 26 hours in. Like the third course, the fifth lecture, and then he starts talking about adjoint. It's like, oh!
Yeah, I hate the fields that are like this, because they like physics is also often like this when you learn from it from history, right? Like they want something, they get it, and then they spend like 6 years building all the things you would have needed to get to the point that you got by just imagining it. But then you need to build the whole infrastructure to convince others. But then they start teaching you from the beginning. So then you start wondering, why the hell, how did you come up with these things? Doesn't make any sense.
That was my biggest complaint about physics, is I finished my physics degree and I got to like 1895.
Yeah. It's kind of like sausages. Once you realize how they came up with some of these things, you start like questioning it. Maybe there are other ways of doing it. I don't know.
Nicely put. Yeah, I will find that book. I think you'd find it very interesting.
Okay.
The little book. Would you like to do a project together, Pine? Like, do you want to try and simulate some ants together or something? Because I do have the Unity skills. So learning Unity is slow. Like it's a big ass thing, and there's a lot to learn, and there's a lot of history in computer graphics, and a lot of people miss the history, right? Mm-hmm. So if you have an idea in mind and just want to kind of get a kickstart and heading in the right direction, I'm very keen.
So maybe I run something by you quickly. We can discuss in more detail later. So I am collaborating. I'm trying to establish a collaboration with a professor at University of Alberta. So his team focuses on human AI interaction, human AI collaboration, adversarial, and all these things. So he has he has 24 students and many projects, some with government, some just like, and he's open to collaboration. So one of the things that caught my eye is they have these human AI teaching sort of platforms. So let's say you want to learn physics. So this is my example, but you can use it. So this is what I'm thinking to do, to use, let's say, reinforcement learning as a way to fine tune the style of teaching to the individual who's learning. So this would be, so they have a project that they're training like pilots. And the idea is, so normally there is some curriculum you go through, you do the test, and some people are faster, some people are slower. You might be good at certain things, not good at other things. Ideally, your training program that's automated learns by interacting with you what is it that you need, or what kind of interaction you need more of, what kind of things you already know, so you don't need to bore you with it. And it would just tune, and it would just learn over time how to give you the instructions. So imagine like a personalized automated training system for subject X. I don't know what the subject would be, but that sort of thing, I feel like it has commercial value, especially as cost of education goes up, more and more people want to get trained, but maybe people have different talents, different backgrounds. I don't know how feasible it is to fully automate the whole thing. Maybe that's too much. Maybe you need to find the small enough projects. Like I think like training pilots could be a good example, because it's pretty, I guess, well understood what the pilots need to know to be effective. So you can test different aspects. But if you want to teach someone to be a mathematician, maybe this is not the best way, because it's more complex and even humans don't know how to do it. So
I'm very interested, Pam. Very interested in that.
So
yeah,
maybe we can involve, like, build something in Unity or something else that tries to teach. So it could be, so I don't know if, do you know the company Roblox?
I do.
Yeah, so one of the things they do, they use games to assess people's abilities, right? So it could be for interviews, for school, or whatever. So this could go hand in hand, right? Like if you have a system that through the game can assess your ability, it could also recommend what you should do next to improve your ability. So that's sort of, I'm thinking of it in terms of like a
company. On
company.
this topic, but yes, I'm genuinely interested in that and would love to collaborate. So let's. I mean, this is being recorded, so perhaps we should drop off and do this offline. But no, I've genuine interest from me, and I have partners who would also be able to help. So
okay, cool. Yeah, so I'll do some legwork of some of the options. Maybe you think about it too, and we'll set some other time. Yeah, I would love to do projects. I have so many like that are like half started, half open. I don't know where they're going, but it would be nice to focus on one thing that could actually be helpful.
Cool. All right. Let's pick that up. Okay. I think we're pretty much at time here.
I just wanted to share this paper with you as well, maybe for the reading group, maybe future session. I thought that people would find it interesting. Let me just share that. So this came up in another group that I'm attending. It seemed to be aligned with what we discussed with the rest of the group many times.
Okay.
It's a short paper. I just shared it, and maybe have a look, see if it's interesting.
Now. Okay, I'll definitely. Well, why don't we do this one next time then?
Yeah, because I can't remember what we decided to do last time.
Rob posted a very interesting TWIML talk about a woman who is studying kids development. This is the Blickett test. I don't know if you remember the Blickett test. Where
Yeah, I think that these two things might actually be aligned. So maybe we should listen to that and read this and find connections. Because I feel like that's how humans learn too, like a tension between explanation and prediction. So that's probably how kids do it as well.
Fascinating. Okay, I'll definitely have a read. Okay, great.
Awesome. Thank you very much. Have a good day.
Great. It was wonderful to have a chat. Take care.
Yeah, you too. Take care.
Bye.